Welcome to the Graphisoft Community Workflow Webinar Series, episode number 5. I'm your host, Nathan Hildebrand, and today we have Jon Anderson from Hive Engineering, who's based from Melbourne in Australia. So our accents today are going to sound quite familiar, although mine's a little bit hoarse. Now, Jon's been using Archicad for over 18 years, and I'm actually going to make a claim today, a pretty bold claim, that I actually think he might be the longest user of Archicad that is solely using it for the purpose of structural engineering. So for those that are watching today, and you've been using it and you're a structural engineer and you've been using Archicad, drop in the comments how long you've been using Archicad for. But for those that are watching us on replay on YouTube as well, drop it in the comments as well how many years as a structural engineer you've been using Archicad, because it'd be great to see how many are out there that are using Archicad for structural engineering purposes well before Archicad was ever designed to be done and used by Archicad users for structural engineering. So I've got myself a bit tongue-tied there. But in today's presentation, structural engineering and Archicad, Jon's going to demonstrate processes, workflows, and tools that he's actually built himself to assist him to get the most out of Archicad to produce structural engineering deliverables. And once again, I'm talking about engineering deliverables well and truly before structural engineering was implemented into Archicad several releases ago. Now, throughout the presentation, if you have any questions, please put them in the chat. And at the end of Jon's presentation, I'll ask those questions to him on your behalf. So, Jon, now I'd like to hand them over to you, mate. Take it away, and let's show what you've been doing in Archicad as a structural engineer.
All right, thank you, Nathan. That was great. I'm going to share my screen and go through some stuff. Just bear with me one moment. Okay. All right. So, as Nathan said, I've been using doing structural engineering in Archicad for quite a while, actually, and I use it on every project that I do. So I'll just give you a brief introduction to myself and what I've been doing. So I'm a civil and structural engineer with 25 years experience based in Melbourne. I've done pretty much all my work in this area. I don't tend to work internationally on projects or anything like that, so it's all local to the Australian market. I've got a small consulting firm, Hive Engineering, and I work as a sole practitioner basically, and that has some advantages in terms of being able to choose what direction I'd like to go in with the CAD software and that type of thing, and that's been a real advantage. So I'll just introduce you to some of the work that and how it's all sort of come about. So I started computer programming when I was a kid, basically in 1985. Learnt BASIC by myself. Then, when I got to university, I did, engineering and mathematics were my main subjects. And then in 98, I started as a engineering consultant with a medium-size firm doing big commercial projects, mainly in Victoria. It was around 2005 that I conservative reaction from my bosses at the time, and they weren't like overly interested in engineers touching CAD stuff. And then it coincided with me meeting a couple of architects who were heavily involved in Archicad, and they introduced me to the software in 2005. So that was the first time I'd seen object-based CAD, and it was a sort of significant diversion in my career. So we went and started a joint consultancy in 2005, and then I spent a couple of years with those guys. And a lot of the development work that I did on libraries and that type of thing, and just working out how you will actually be able to deliver a project, was done in 2006. And that was a really interesting process of, developing tools, working out what works and what doesn't work. And then in 2007, I moved into another role with an established architectural firm, and we were collaborating again with Archicad. And then in 2008, I started Hive Engineering, which I've been going continuously since then. And that focuses on structural and civil engineering and Archicad. There's been a few kind of milestones in that. 2010, we did a BIM pilot project for the Victorian Department of Health, and that was an interesting one because in that the architect was using Archicad, and we attempted sharing models using teamwork, and there were a whole lot of lessons learned in 2010 as a result of that, and what works and what doesn't work in terms of model sharing and that type of thing. And that was quite instructive. The other things that were kind of interesting was in 2011, I wrote an add-on to basically plug in with Grasshopper. This, I guess, predates the one that Graphisoft now have implemented fully into the software. But that was sort of an interesting thing as well. So I visited Graphisoft in Hungary in 2022, and then since then I've sort of been working on upgrading to a newer version and automating some of the processes that I've been doing. So that's the background. These are the type of projects that I do. So these are some of the images from projects that I've delivered. So I do a lot of schools and community facilities like police stations, ambulance facilities. That tends to be the type of projects I do. There's some which are quite architectural. Like you look in the top right corner, there's a picture off a book of a school that I did. There's been a number that have won architectural awards in Victoria and in Australia at a sort of architectural level. I go through and I model everything at every stage in all those projects. These are some of the snapshots of the front page of all of my drawing sets. So I usually start the drawing set with an image of the structural model, and I think these are quite good because you can sort of see the models and the level of detail that I'm going into on these projects. All right, so that was a brief introduction. I'm going to go now and just talk about Archicad and ask the question, is it a good tool for structural engineering? So in 2005, when I started, Revit wasn't really a thing that you could use, and no one had heard of 3D modeling and BIM really in the engineering space, or very few companies had done that in Melbourne anyway. So there were some things that were really quite good, and that make Archicad a great tool. I think it gets really clear documentation, and you can produce nice coloured sort of images, and clarity of communication is really good with Archicad. I like the interface, and I think the modelling is really fast with Archicad once you get used to and set up all the tools and everything. So I find that I can deliver stuff very, very rapidly to my architectural clients. I think it's quite powerful that it's object-based, obviously and it's information-based, being a CAD software, and that has all of that integration. And then the mathematics and the GDL has been the real powerful bit, because it meant you're dealing with maths generally with engineering, so it kind of plugs in really quite well with what we're trying to achieve. And obviously it's compatible with what the architects are doing, so that works quite well with a lot of the clients, so that's been great. The other big challenge is that structural engineering elements are presented differently to architectural elements. I'll go through these on CAD in a moment and just explain in a bit more detail. The other thing that's significant is structural elements are often on inclined planes, like roofs, rather than on flat surfaces, like, like a flat story. So, I've got to get all the structural elements to align to a roof element, and that's very important. And then the other thing that's a little bit surprising is that structural engineering drawings aren't actually exact. They're more of a schematic thing. So again, I'll go to some detail on this. And then we also design structural elements in groups, not necessarily individually. So I'm going to attempt to jump onto Archicad now, and let me know if you can all see that.
Oh, good.
Right. So yeah. So I'll go through these obstacles a little bit. So for the engineering elements are presented quite differently to architectural elements. So we care very much about, this is just a little mock-up of a building, care very much about what's underneath the slab. So this is a just a simple, hang on, not that one. Just a simple concrete frame, just to show you. And I would represent that using the slab tool mainly, and the column tool and the wall tool to generate something like that. But we very much care about what's underneath rather than just what's on top. So we have dotted elements showing columns under and solid elements showing columns over. So you can read that, you might have a column over and a column under coinciding, something like that. Unfortunately, I have to use fills for the column under because to get that to present properly, you'll have that. And that's one of the challenges, I guess, is you have the elements in Archicad and then presenting them. I think there's rumours that the Archicad 28, I think I saw something that there might be some development in this space in terms of making it a bit easier to present what's over and under for structural engineers. So that one's definitely a consideration. The other one, which is interesting, is that you've got elements that are connecting onto roof planes. So you have challenges like this, where you might have like a 10-degree roof meeting a 20-degree roof, and then you need to run a beam along the ridge line. Now, the beam tool, it's really difficult to model accurately with that, because you might have, if you've got something running along a diagonal to both roof planes, it's going to have an angle that's significantly different to both angles. So this one, in this case, would be running at 9.55 degrees along that line. And then you have to align all of the members to that. And then if you have anything running at an angle to the roof plane, like a beam that runs through like that, it has a pitch and it also has to have a roll. So to model things accurately, I've had to develop my own beam objects rather than using the beam tool, because it's just very difficult to actually align all the elements to a roof. A good example was a little while ago, I did a building which was just a single plane roof, and I'll show you one that's similar in a moment. And the architect had one element, which was the roof plane, and then I had something like 150 elements linked to that roof plane, and so if the architect is going to move it and change the pitch of the roof or something like that, obviously to realign, if they went from 2 degrees to 3 degrees or something like that, to realign 150 elements is a hugely time-consuming thing. So the tools that I've built can align to roofs. So I'll go through that in a little bit. Yeah, so the other thing is that the structural drawings are actually schematic. So we generally would draw like a beam stopping short of a column with a little bit of a gap. Otherwise, it becomes quite unclear. And then, might represent the purlins or the secondary elements with a double line, and perhaps with a different color like that. So again, the elements that I build with have some of that smarts built in so that they can represent properly. And here's another good example of structural drawings being schematics. So if you look on the right side, that's like a section with reinforcement drawn perfectly to scale, which is pretty much impossible to read. And then the way that we would normally draw that would be as line work with, and that's obviously not to scale, and things are offset, so you can read each bar in a separate element. So again, that's a bit of a challenge when it comes to how you deal with reinforcement and modeling reinforcement. Again, with steel details, you might have the same issue, like drawn to scale. It's very hard to read, something like the purlin thickness, which might be like a millimeter, and you would tend to over exaggerate that on the drawings so that it's a bit clearer what you're actually looking at. So you can see the one on the left reads much clearer than the one on the right. So that's what I mean when I say they're schematic and they're not exact. And then the last thing was that we tend to design in groups. So if you look at those three, I would tend to design a group of joists, so that I'll show you that as a 3D element. So that's a group of joists. So that's not one element, that's multiple. And then that would get designed as a single group, and that they're all the same thing. Like you wouldn't show every joist in plan. You tend to show an extent, and you don't generally care exactly where they go. You only care about the maximum centers between each one. And then obviously the real length of the member, if you drew them individually, might be shorter. So again, that's a bit of a challenge because you don't want to have to draw every single stick if you're doing it as a group. So yeah, so that's a bit of an introduction to that. So I'll just go back to, yeah, so what I'll show you next is I'll just show you one of my projects. This is a very simple one, which will probably explain a little bit more what I do. So this is just a toilet block out in the middle of a park for a council. And this is basically like the other one where you got a single planed roof and everything links up to that roof. And yeah, this is a fairly small project. This model would probably take me something like a day or a day and a half to put together, something like that. It's got all of the drainage and everything built into it, wall bracing, all the rest of it. Yeah, so that, and then off that, I get all of the drawings come off that, and then you end up with like the drawing set. And I would typically produce for I'd typically produce like a front page, and that's straight off the model, and then plans of each level showing like all the notes and everything, and the roof plan, and then some roof details. So that's a very, very simple job, but I think it sort of shows where I'm trying to end up with the elements. So they're all my own steel beam elements and my own timber beam elements that make up that roof. As I use a setting in all of my objects, which is the clean wall thing. I can use that as a toggle, and then I use that as an editing mode. So then I can, in each of those elements, I can set a pitching line. So this has got like the pitching line for the roof. So each of those elements is linked to the pitching line of the roof, and then it can automatically calculate like wherever it is, it's still pitching off that line. So that gives them the height, the slope, and the rotation. And then that's how I get the model to look accurate. And then if I've got all of that, I've also got the walls and the typical simple project. I'll talk briefly about process for delivering and how I go about delivering a project. So typically my projects are fully documented. I tend to have projects that are what we would call a traditional procurement, in that you've got a client and they're basically putting it out to tender, and then a builder would engage to build it on, and we're engaged by the client, we're not engaged by the builder. So that keeps it, that's generally the type of projects I work on. The architect is generally the point of knowledge in all of the projects. So they're responsible for the set out and the dimensional accuracy. A lot of my clients use different software. So some use Archicad. There's a lot using Revit in Australia. AutoCAD still, SolidWorks, Rhino, SketchUp, and I can work with any of those really. That doesn't tend to matter. The builder is obviously responsible for the final coordination of the project. So they will take our drawings, the architects and the engineers, and create shop drawings and all the fabrication from that. And then the building surveyor is responsible for the site sign off. So that's typically the way projects operate. So my process is obviously to take the information I receive from the architect and produce a set of drawings that go to tender or construction. So the way that tends to work is I've put a step 0 in, which is I have done a bit of work on my template, and that's always important, I think, to get efficiency. So I've got my own layers. I use my own pen set, which I try to keep consistent. The attributes, I try to use attribute numbering that is not going to clash. So I tend to use very high numbers for my attributes, like that type of thing in the. And yeah, so then the process is I'll receive the information from the architect, go through a process of setting up the model. And I'll talk to a bit about that because this is quite interesting. So the first thing is I always match my location to the architect. So in terms of where it sits in plan. So I'm going to model basically inside the architect's model. I always match the stories to the architect's stories, because that way, if I hot link in the architect's model, then my model and the architect's model will always end up in the same place with all of the stories matching. So that's those two things are really key to making sure that the models that I produce are useful when I send them back to the architect. Quite often, particularly when I'm using models and that are coming out of Revit and that type of thing, I'll use a 2D XREF at each level when I'll put the plans in, and then I'll hot link in the 3D as a separate element. I have the architectural layers as a layer combination so that I can see what's going on, and that's separate to what I do. And I set up all the views using cloning, and that helps a lot. A lot of people aren't aware of this, but there's a wireframe that you can set up in the actual layer combination for some layers. So I always set up the architects as a wireframe, because then I can model directly inside their model. Yeah, that's enough on that. So then the first step that I go through once I've set up the model is I model the architectural elements, so the walls, the floors, the columns and roofs, that type of thing, and then all the surfaces. And then the engineering elements, I model them second. So, all the framing that might support that roof or the, wall or whatever goes in next. pipe work, reinforcement, all the fixings and what have you. And then having guessed all that, or like done an intelligent guess, I'll do an analysis on it and then basically go back and repeat through that process until I've got something that works. And once that's working, I set up like the 2D drafting and annotation and the drawings, and then that goes back to the architect for them to review. And then as it is, we go around again, we repeat until that's coordinated to go back through the architect, and then finally it'll get issued to site or issued out for tender. So that's typically the process that I use. I'm going to open another one. This might take a second to open actually because it's quite a big model. But I was going to open up one that's been built. So this was a fairly large school that and I might just note before I do, you might be wondering why I'm using Archicad 24, and I use Archicad 24, 25, 26. Haven't really used 27 much yet. I have to be careful with the libraries that I've got because I can't bring a library that's done in or saved in Archicad 26 back into Archicad 24. So if I've got an architect that's still using an earlier version of Archicad, it makes it really difficult if I bring my library forward. So I try and keep my library back a few versions. So Archicad 24 is a fairly stable release in that I'm pretty happy with my library working well in that, and I'll gradually evolve that, as the architects move and they all move through into like newer versions of Archicad, and then I'll save it into 26 or something like that. Probably would be the next one. So this model's still opening. This was a fairly big school. I'm going to just bring it across to the other screen in a sec. I probably should have opened this one before I started. But, okay, here we go. Right, so this will give you a bit of an example of in the model. I've got the architect's model here, and the structural model is modeled sort of effectively inside it. So you can see the architect's model is in the wireframe. So as you model, you can align doors and that type of thing to the architect's model, and that makes it fairly efficient to do the modeling and make it accurate. And then all the 3D drainage elements are done in that as well. I model, which is I guess a little bit unusual. I also model reinforcement, which I've got. Get the scale right. Yeah, so I've got my own reinforcement elements that I can model in, and then they're all 3D. And I'll show you the way that looks in 3D. So I can fold and bend all the reinforcing bar, and then the documentation. Yeah, so this was a post-tension concrete slab. So you can see the drapes on tendons and all the reinforcing within the structural element, and all of the actual drawings that they used for the design, the actual fabrication, comes straight off that. So each of those is a group of elements that I can edit and modify. Yes, so I can get a group of elements and then change the number of bars or whatever in that group, and it'll update in 3D and 2D at the same time. And then I can also you can see I'm getting the quantities of the mass of reinforcement at the same time. So I can use the scheduler to get all of that information out for the whole project and work out what the reinforcing quantities are, which is which is pretty powerful, really. So that, I think that's a fairly good demonstration of that. I might show you quickly civil stuff too, because that's pretty good, because you can also with the pipe elements that I use, they can be dragged up and down in 3D, and then you can get the actual elements will give the invert levels of the pipes. And so it's really easy to just connect it all together in 3D, and that'll give you all of the grades and flows of the pipes. It's all based on whatever grade the pipe is. But yeah, anyway, that's that one. I'll go back to the presentation again and find it. Yeah, so I guess the next thing is how can engineering be optimized using Archicad? And there's a few things that kind of come to mind. This is a quote from 1911, which appealed to me, that civilization advances by extending the number of important operations we can perform without thinking about them. And it kind of sums it up a little bit with what we're doing with BIM, that if you can actually automate a process and then you're using smart elements rather than sort of grunting it out, it makes it much more efficient. So the things that I tend to focus on are things like hotspot editing, like the movable hotspots. I do something which is probably a no-no to a lot of practices, but I hard code all the pens into the objects. So I never have to worry about what pen thickness and line type, because that's all hard coded in, and that makes it really efficient to make those tools. There's some tools that I use where I can read information straight from the model. So things like, accessories, which can be quite useful. The GDL is quite good because you can make really complex tools with that are reactive to the shape. And I'll show you a couple of those. And then there's a huge future in automation and automated calculations and cutting of beams and all the connections and all that type of thing. So I'll just go back into Archicad again. And just show you a couple of the things that are kind of interesting. So like this one here is that's good. Yeah, so if I take that simple little structure again, you can attach things like accessories, which can read the wall thickness. So this is one that I would use for nominating precast concrete panels. And then when you actually show them on elevation, they're all labeled, which is really fast, particularly if you're documenting like a building with lots of precast in it. I use tools like I'm missing somewhere here. Yeah, so this is a tool I use for columns, for automating the column, and basically they're reactive to the shape. So you can see the reinforcing on those changes automatically with the shape of the column. So you can automate some stuff into, and again you can pull quantities out of it. So having reactive smart tools is really efficient to be able to do things like that. So, I wrote these probably at least 10 years ago, but they're still very useful tools. There's a lot of other tools in my library that I use for 2D drafting and things like that too. So there's you can put yeah, you can put like some smart like objects together, and then they may scale. There we go. Yeah, so you can take an element and then you can build in the GDL script, you can build smartness into it. So it'll adapt to the actual shape of itself. And then you can build up like from 2D elements, like some quite clever, you know, detailing and make it really rapid using sort of smart objects. So then you could put you could put like a concrete wall element or something like that that might have some notes built into it, and then be able to bring your bars in and just bend them into it. And like having smart tools for 2D is just as valuable as having smart tools for 3D, because if you're doing detailing, it can make it really really effective doing that. And then you might have it so that you have a thinner wall which might only have one set of reinforcing bars down the middle of it. So you want to have these adaptable tools, and there's some great efficiency in that. I use some smart tools for doing walls, like internal stud walls and that type of thing. And then in those, I'll show you quickly one of those. So that's a sort of smart stud wall, like that. But into that, again, you can use the hotspot editing, and this is a good example where you might be able to grab an element and then go, I'm going to put some door openings into it, and then there's a lintel built straight into it, and you can very quickly put together frame up a building with like multiple door openings or whatever. And then that all kind of comes together quite quickly. You can change the bracing. Again, they can link to the roof planes and then adjust in height and all that type of thing too. So yeah, there's quite a lot of power in GDL. And like if you can write these complex scripts into the GDL, you can actually get like a lot of efficiency out of that. I probably won't go fully into like the detail of what I'm doing next, but I'll give you a bit of an overview of where that's up to, and it's a work in progress. And I was hoping to give you a little bit of a demo, but it's not working perfectly today, so I'm not gonna show you that. But what I'm sort of looking at doing is some automation of the process. So things like I'd like to be able to rapidly model in Archicad because it's a fast tool, but there's a lot of automation that probably needs to happen outside Archicad, in terms of things like cutting against other elements and producing IFC, doing calculations and all of that compliance stuff. So I've been involved in this process. So I can basically take a model of all those individual elements and then split them up in IFC so that I end up with like all individual elements that can come back into Archicad or whatever, and then automatically produce calculations and that type of thing. So that's kind of the direction of where I'm going with that. But I won't go into a huge amount of detail. Perhaps maybe I'll just show possibly one. I'll just show you quickly an IFC model that you can kind of get out of something like that. Actually, I'm not going to do that. That's not going to work. Let's no, I'm going to pause on that. Maybe that's okay. I've got Yeah, it's blown up a little bit, but this was one that I was hoping to show you, but this is in Celebri, showing the beam cuts and that type of thing that are automated out of Archicad using sort of smart objects, I guess. But yeah, that at the moment that's not working, so I'm going to apologise and say that I can't demonstrate that. I was hoping to give you a bit more of a demo on that one, but yeah, that's basically it for today. I think that's probably enough. And I'm happy to answer some questions if you've got some.
So thank you very much for taking your time for presenting today.
No problem.
Now, if you want to catch us on future webinars, we are hosting these on a monthly basis. The time of day is different because we cycle between the morning and the afternoon in Europe, which then also means that we have different attendees across the globe. So what I recommend that you do is over on the Graphisoft community page, by building together webinars, subscribe to that page so you can see the updating or the latest webinars once they become released by the team. Now we will be hosting another webinar in a month's time, but that will be announced shortly, hence why we recommend that you take the time to subscribe to that update on that channel. I think that is all for today. Other suggestions I have for you, maybe you could watch back on the recent podcasts that we've released as well through the Graphisoft community as well, or on the Graphisoft YouTube channel. Been some great interviews there where we're learning a little bit more insights about some of the team members from Graphisoft. Other than that, thanks very much for your time this afternoon, and I look forward to seeing you next month. Have a great afternoon, morning, or evening, depending upon where you're watching today. Thanks very much.
Thank you.